Hey there. Hope everyone's hanging in there. We're jumping into O-level physics, lesson 3, sound and the electromagnetic spectrum. Sound is a longitudinal mechanical wave produced by vibrating sources. Air particles oscillate parallel to wave travel, creating compressions and rarefactions. Sound requires a medium and cannot travel through a vacuum. Its speed depends on medium properties and is generally greatest in solids and least in gases. A bell jar demonstration becomes quieter as air is removed even though the bell still vibrates. Frequency determines pitch, while amplitude relates to loudness and energy. A waveform display plots microphone signal against timed period is measured between corresponding peaks and f equals 1, all over t. If 5 cycles occupy 0.010 s, t equals 0.0020 s and f equals 500 Hz. A louder sound has larger amplitude but not necessarily higher frequency. Waveform shape contributes to quality or timbre. An echo is reflected sound. Distance to a surface equals speed x round-trip time 2. If an echo returns in 0.60 s and sound speed is 340 m over s, distance equals 340 x 0. 60, all over 2 equals 102 m. Ultrasound has frequency above human hearing and is used for medical imaging, cleaning, sonar, and non-destructive testing. Short pulses allow reflections from different boundaries to be separated. All electromagnetic waves are transverse and travel at about 3.0 times 10 to the power of 8 m over s in vacuum. In increasing frequency the spectrum is radio, microwave, infrared, visible, ultraviolet, X-ray, gamma. As frequency increases, wavelength decreases because c equals f lambda. Boundaries between regions are not sharp, and visible light is only a small part of the continuous spectrum. Uses follow interactions with matter. Radio waves broadcast and communicate, microwaves link satellites and heat food, infrared supports heaters, remote controls, and thermal imaging, visible light enables vision and optical fibers, ultraviolet causes fluorescence and sterilizes X-rays image dense structures, gamma treats cancer and sterilizes equipment. The same wave type can have several uses depending on frequency and power. Risk generally rises when radiation is absorbed. Microwaves and infrared can heat tissue, ultraviolet damages skin and eyes. X-rays and gamma are ionizing and can mutate cells, so exposure is reduced by shielding, distance, and time control. Benefits and hazards depend on dose, not simply the name of the region. Sound hazards instead involve large amplitudes damaging hearing over time. 4 wave traces measure several cycles and divide to improve period precision. 4 echoes identify the measured round-trip time and divide by 2. 4 spectrum questions link each use or hazard to a physical property. An ultrasound pulse returns from tissue in 130 microseconds at 1540 m over s. Depth equals 1540 x 130 times 10⁻⁻⁶. All over 2 equals 0.100 m, approximately 10.0 centimeters. Do not say loudness determines pitch, forget the factor of 2 in echoes, claim sound crosses a vacuum, or state that different EM waves have different vacuum speeds. Practice. An echo returns after 0.40 s. Use 340 m over s to find wall distance. Answer. Distance equals 340 x 0. 40, all over 2 equals 68 m. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. Practice. Explain why X-ray exposure is controlled and name 2 controls. Answer. X-rays ionize atoms and can damage or mutate cells, reduce time and use shielding or greater distance. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. Alright, that wraps up sound and the electromagnetic spectrum. Next time in O-level physics, we'll get into electrostatics, charge and current. Take care, and I'll see you in the next one.